Gravity is not a force. This is a bold claim, I realize, contradicting what we are taught in physics classrooms, but it is a claim I can substantiate fully. Picture a man falling from a roof of a tall building. Now, while he is falling, if you were to let go of anything else, like a bucket, then relative to him, it would stay stationary. Now, picture another man in a rocket, far from any large masses, moving in space at constant velocity. See any similarity? The rocket, relative to Rocket Man, is stationary, and the bucket, relative to the other man, is also stationary. However, both men, the rocket, and the bucket are all moving. Another similarity between these two scenarios is that both men do not feel their own weight. These men are what are called inertial observers, meaning that they feel no acceleration. They are in no gravitational field, or gravitational field as we will see, and all laws of physics apply in that reference frame, aka everything relative to them. Prepare to have your mind blown. I lied early on when I said these scenarios are similar, because physically they are completely equivalent. Now, the man falling from a roof is accelerating, you say. However, to the man, he feels just as he would if he was in space, drifting at constant velocity. In scientific terms, their inertial frames of reference, or everything around them relative to them, are the same. Let's continue this mind-bending thought experiment. Let's assume Rocket Man is approaching a planet in the distance. Now, to an external observer, the rocket bends towards the planet, as you would expect. But Rocket Man experiences no acceleration and does not feel any force exerted on him. His inertial frame of reference is the same as was before. Now, to clear up something, as the rocket approaches the planet, it is accelerating, but Rocket Man cannot feel the acceleration. If the rocket had an accelerometer, its reading would maintain 0. Essentially, Rocket Man's inertial frame of reference would stay the same up until he crashed into the planet. But then, how did the rocket's path curve towards the planet if gravity is an illusion? Geodesics and curved spacetime. Now, whilst the rocket curved and sped up, Rocket Man felt like he was moving at constant velocity through a straight line in spacetime. But here's the thing. Moving straight in space-time is not moving straight in actuality. Space-time is curved around large masses, like the aforementioned planet, resulting in a straight line through curved space-time, creating a curved line. But only people spectating will notice the bend. Rocket Man will still think he's moving in a straight line. Now here is another thought experiment. If you travel in a plane from London to New York, what would the shortest distance between two cities look like? To a passenger, it would look like a straight line from London to NYC. After all, the plane flew in a straight line. But to an external observer, that path would be a curve. Why is that? Because the plane traveled in a straight line relative to a curved surface, which means that the shortest path is indeed curved. This is called a geodesic, and it is the same property that causes Rocket Man to feel nothing whilst an external observer watches him speed up towards the planet. Still confused? No problem. Imagine two people standing on different meridians on the equator. Now, both of them at the equator are about 1,000 kilometers apart. They start walking due north in a straight line. Eventually, the 1,000 kilometer distance between them decreases to 100, then to 10, then to 1, until they meet up at the North Pole. Now, both of them traveled in a straight line. Neither of them felt a force pushing them towards each other. Yet, the distance between them magically reduced to nothing. This is the power of geodesics, and the reason why Rocketman feels nothing. Gravity is actually an illusion. Now, what happens if Rocketman turns on his engines and accelerates at 9.8 meters per second squared? In his inertial frame of reference, he and everything around him falls to the floor of the rocket, whilst external observers will see that the rocket moved into Rocketman and everything else. Rocketman would now feel as if he was at rest on the surface of Earth. Now, this scenario and you at rest on Earth are not similar, because yet again, they are the exact same thing. You are at rest because Earth pushes up into you. However, if Earth pushes up into everyone, why does it not expand? Again, geodesics. Earth is a large mass, so space-time curves around it. Curved space-time means that Earth can move into you with a force of 9.8 newtons, and you accelerate upwards, without the Earth expanding. Sounds illogical? Yes. You do not feel like you are moving up, because the Earth is in your inertial frame of reference. The Earth is stationary relative to you. You do not feel the Earth spinning because you spin with it. Same with your upwards acceleration at 9.8 meters per second squared. How can we notice this upwards movement? Ask that man who was falling from the roof. For him, Earth and everything on it move up. Acceleration is a deviation from a geodesic. There's more. If you want to be at rest in curved space-time, then it is basically mandatory for you to be accelerating, as one equation from general relativity shows. Why do objects fall at the same rate? It's because they are not falling. The Earth accelerates into them. As absurd as this sounds, it is true. And no, this is not a flat Earth theory. The Earth is round, and this phenomena occurs because the Earth and space-time around it is round.
But precisely because of the obscurity of our world thus revealed,